Hello again, and welcome to my series of solving LeetCode problems, where I'm solving each problem individually, starting with the easy ones and going to the hard ones. So let's go. Next one is search insert position. I wonder what this is. Okay, so give an assorted array of distinct integers and a target value. Yeah, this is sorted, target. Return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with O log n runtime complexity. So, what is O log n, if you're wondering? So let's say you have an array of 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is an array. So let me just make it very clear. This is an array. And we want to do something. It's an algorithm that does stuff with an array. And if it takes 10 steps to do the algorithm, because it has 10 elements, that means it's complexity O(n). So worst case scenario, it takes n operations because it needs to go all the way to the end. And it's the same thing. Let's say if it was 11, then it would take 11 operations. If it was 20, the 20 elements, it would take 20 operations. And let's say if it was 20, it would take 40 operations. If it was 30, it would take 60 operations. It would be 2n. But we always look at the n itself. So what grows and how does it grow? So it grows proportionally to n. In this case of log n, if you want to know what log n is, it's pretty much how many times you can divide something by something else. So let's say you have number 10 and you want to divide it by 2. You divide it by, let's use number 16. 16 divided by 2 equals 8, which is divided by 2 equals 4, which divided by 2 equals 2, which divided by 2 equals 1. So we can divide 16 1, 2, 3, 4 times. So let's just search log 16. Oh yeah, this log base 2. Base 2. Uh-huh. Gosh, really? It's 4. So log 2, 16. When we don't have 2, like something underneath, I think it's base 10. That's like let's try this. 100. Yeah. How many times you can divide 100 by 10? It's 2 times. So, if you know your algorithms, one way of doing this, the search insert, is pretty much you want to find the position where it is. And how do you find it? You could iterate over the whole array and find the first time the value is bigger than the target, and then that's where you insert. But let's say the value is, in this case, it would be 500. So you'd have to go all the way to the end. One strategy to do this is with the binary search. So what you do is you basically go to the middle and you check in the middle if the value, like if you're in the middle and you don't know where to go, like go to the left. And you go to the middle and check this value. Oh, is this value bigger than our target? Well, I guess not. Well, then let's just let's take this half out and let's just use the other half. And then we repeat the same process. And okay, let's go to the half. Oh, we found a 5. Great. So let's actually do this. So it's 35, search, insert, position. I hope I made sense with what I said. So here we are, and copy this, paste this. This is something I'm doing every single video. Okay, from imported from the place. I'm typing, and now just a test case solution. Create the object based on the class, and now search insert, and the argument is here. What's going on? Okay, so now first thing we do is let's check the left index, and we start with 0 because we're going to search for the entire array, which is 0, and the right index, which is the length of nums minus 1. So now we need to, I'm actually going to do this in 1, 2, 3, 5, 6, 7, 8, 9, 10. I'm going to do it with the bigger one, otherwise it's a bit hard to look at. So also the type, integer. And now we check for the, so let's just do while true. And let's check the middle position. It's equal to left index plus right index. And we want the integer division, right, too. I think this is the integer division. Let me just make sure. I want not this. I want a Ubuntu Python. So it's let's say 10, 11 divided by 2, 5. If it was 12, it would be 6. It's 10, it's still 5. Okay, so this is what I want. This is the integer division. Middle position. So if middle nums of middle position is bigger. Okay, let's just do equal to target. We return, what were we supposed to return? Oh, it's the, well, yeah. We return the middle position, we return the index. And if we don't find it, we return the index where it should be. Yeah, okay. So, okay. So, while left index is different than right index, because once they meet, we know for sure that that's the position where the number should go, the target should go. So if it's not equal, then else if the number in this middle position, if it's bigger than target, then we don't care for. So if the middle position is bigger than the target, we want everything that is to the left. So we can do something like right index equals middle position, and else left index equals middle position. And then worst case, when they meet, the loop breaks and we just return either left index or right index, doesn't matter. So let's give it a shot. It's running forever. 2 and 4. Okay, let's start So left index is 0, right index is 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this is not going to be equal because the middle position is 4. 1, 2, 3, 0, 1, 2, 3, 4. So the number is going to be 6. No, it's different. But it's going to be bigger than the target, 6. So right index is now 4. 0, 4. So now middle position is 2, which is going to be lower. So now middle position is, oh, yeah, okay, get it. It's kind of looping everywhere. Let's just do something like this. -1 plus 1, because we know that they don't belong. Okay, free. It works. So let's just try with this. See where it goes. 2. It's supposed to be 2. Yep. Okay, I'm feeling confident. Let's just insert it here. Submit. Failed on the first one. Output 0. Hmm. Target is 2. 0. Left index is 0. Right index must also be 0. Yeah. Okay, where did it go wrong? The middle position is 1. Left index is 0. 3. Oh, right. Not that simple. Okay, so let's go again. So I'm having like a tough time just getting like the center. So 0 plus 3 equals 3 divided by 2 is 1. The number in the middle position, I need to get a new mouse. It's 3. And our target is 2. So we know 3 is bigger than the target, so right index becomes yeah, maybe this is the problem. I can't do this subtraction. 0 plus 1. That's the middle position is 0. And the left index will still be 0. We don't want that. Okay, I'm gonna do some cheating here. I want it to be equal to it, But if it's the same, I want it to subtract or add. If it's the left, subtract. If it's the right one, add. So right index equals, what's going on with my mouse? Equals middle position minus 1. Else, and now it's the same thing. Right. We just replace right with left, and instead of subtracting, we add. Left, left. Okay, let's see if this works now. Yeah, I guess this works. Let's give it a shot. Ah, 7. I think I'm overcomplicating this just because I'm trying to rush. The target is 7. Zero, 1, 0, 1, 2, 3. And that's afterwards. 4. Maybe I shouldn't do this. I should do division, and then I should round it. See what happens. Quite work. Okay, let's take it back for a while. So let's go slowly. So left index 0, right index 3. Of course, we're going to update the left index to become 1. So now the left index becomes 2. The right index is still 3. 2, 3. And the middle position is 3. So they're the same. Okay, I feel like this is the moment where we don't really know if it should be to the left or to the right. So return left index if nums of left index is smaller than target. Else left index plus 1. I think this makes sense. Sorry, bigger. So let's try this. Like the logic is here. There's just like a tiny bug. Seems like it's gonna loop forever. Yeah, loop forever on the first test case. Ah, and the target is 2. Let's see what happens. So middle position, left index is 0, right index is 3. Yes, the middle position is 1, 0, 3 is bigger than 2. So the right index becomes 1. So it's 0 and 1. So the nums of the middle position, which is 0, 1 is smaller than 2. Therefore, left index equals middle position. And it stays like this forever. If I think I'm gonna do that thing that if it's equal, if left index is different in middle position, else middle position plus 1. I think this goes. I'm just afraid that this might break something else. Answer. Oh, well, okay, so an edge case of a number that's on its own. Let's see. Output 1, expected 0. Well, that length of nums equals 1, return 0 if target is smaller than nums first position, else 1. If not nums, return 0. Let's see. Still? Oh, if it's the same. Yeah, of course. If target equals nums 0, return 0. Yes. Always the edge cases. Ah, 2. But it should be the same. Okay, I guess what's happening is that while left is different. Maybe they're meeting, but they are not coming here. Yeah, just solution came. So kind of feels like, okay, let's see. So left index is 0, right index is 1, middle position is 0. Okay, and we check the number of middle position. And then of course, I think we need to check if the num of the this one, yeah, if nums of left index equals target, then return left index. This is taking longer than I expected. Okay, why is this failing? 235 and the number is 4. This is taking so long for something so simple. Time limit exceeded. Left index is 1, right index is 2. Middle position 2. I think I should do the same thing here. If right index it should have the, oh, okay, that's 0, 1, 2, yeah. Time error. Target 11. Where did it mess up? Yeah, of course. If for right index and right index is smaller than length of nums. This is 6. 4 plus 5. Division. You don't say. You don't say. Gosh! Really? If anyone's watching this video that knew about this and didn't tell me telepathically, travel through time just to tell me with telepathy, this was the problem. Should have known there was something silly. Okay. Okay, good. Cool. Uh-huh. I guess I can really improve this. But you get the picture. What you need to do is go to the middle. Let's see, you're trying to put number 1, 2, 3, 4, 5, 6, 7. Let's say you want to put number 8. You go to the middle, so 1, 2, 3, 4, 5, 6. This is the middle. 8. Is 8 bigger than 5? Yes, it is. So you take this apart and you come here. Then go to the middle. Is 8 bigger than 7? Yes, it is. So, and you do the same thing. And then, is 8 bigger than 9? No, it's actually smaller. Okay, so you take everything apart. And you do this. And at this moment, you kind of realize, oh, like left index and right index are the same. So let's say if it's bigger, it's the left index. If not, it's the +1. So it's either left or right. Okay, this one was not something to be proud of, but it is what it is. Thanks for watching.